Thread identification international connections. Tapered versus parallel threads. The first step using this thread identification guide is to determine whether the thread is tapered or parallel. Tapered means the thread walls, if continued lengthwise, would eventually meet. Parallel means the thread walls are straight. A seal must be used for parallel fittings in port applications. Port seats. In both metric and BSPP threads, port applications require a seal of some style for all parallel thread fittings. Here are some of the different style seals for those port applications. Type E elastomeric seal ring. Type G O-ring rigid. Type H O-ring adjustable. Type B cutting face. Bonded washer and spot face. Chamfer and O-ring seal. Flared seat versus ball seat. The ability to properly identify seats, chamfers, and their corresponding angles is a benefit to the fitting identification. Flared seats refer to the protruding nose cone on the male thread or the internal flare on the female thread. Ball or cone seats refer to the nose cone inside the female swivel thread that seals with the chamfer on the inside of a male thread. 24-degree metric compression fittings. Most metric and Kobelco threads are tube application capable because of a 24-degree tapered throat angle that exists inside the male threads. To achieve a tube connection, a tube nut is tightened over the metric threads, forcing a ferrule or cutting ring to grip the tube. When the nut is securely fastened, the ferrule squeezes the tube, which holds the tube in place. O-ring face seal fittings. O-ring face seal. This is a very common fitting in North America known as O-ring face seal, ORFS, but is also used with British threads, HIAB, as well as metric threads, metric flat face. Essentially, face seal fittings seal between an O-ring located in the face of the straight male thread and the flat face seat on the female thread. Measuring threads. After identifying if the threads are parallel or tapered, measure the thread pitch in millimeters over the top of the thread crests. BSP threads come in two versions: parallel, BSPP, and tapered, BSPT. The thread flank angle for both tapered and parallel British threads is 55 degrees. It is a fairly common mistake to identify a BSPT, tapered, as an NPT. Remember that NPT threads have a 60 degrees thread flank angle, and BSPT has a 55 degrees angle. This can be verified with a thread gauge. Although BSP is a foreign thread, it isn't actually metric. This is why it comes in imperial sizes: 1/8, 1/4, 1/2, 3/4, and so on. Use a calipers to measure the outside diameter, OD, of the threads. On parallel threads, where you measure isn't critical. On taper threads, it is important to place the calipers on the third row of threads. Metric thread callout is the OD in millimeters followed by the pitch. Example, M22 x 1.5 or 22 mm x 1.5. BSP fittings can be identified by completing a few calculations to find the thread size. 1. Measure the OD of the BSP thread. 2. Take the OD measurement, inches, and subtract 1/4 inch. Example, the OD measures 1 inch. Subtracting 1/4 gives the thread size of 3/4, also known as -12. Once you have the thread size, it is important to verify the pitch. The easiest way is to follow the following steps. Count the number of thread crest over a 1/4. Multiply that number by 4 to get the number of threads per inch. Example, if you count 3.5 thread crest over a 1/4 and now multiply the 3.5 by 4, your pitch is 14 threads per inch. Now I will introduce about International Thread Standard and all 11 types. 1. British Standard Pipe Parallel, BSPP. 2. British Standard Pipe Tapered, BSPT. 3. BSPP Port ISO 1179-1 and DIN3852, Part 2. 4. Metric 60 degrees cone, DIN 7631. 5. Metric port ISO 9974-1 and DIN 3852, Part 1. 6. Metric port ISO 6149 and ISO 261. 7. Metric tube compression 24 degrees cone, DIN 2353. 8. Japanese Industrial Standard, JIS 30 degrees. 9. HIAB BSPP Flat Face O-Ring. 10. Komatsu 30 degrees flare, JIS metric. 11. Kobelco compression 24 degrees cone.